Hello everyone, I am Keval Behra, a semester 8 student at Marwadi University, Rajkot. I am currently pursuing my BTech in Information and Communication Technology. In this video, I am going to talk about the topic of Bayesian machine learning, which is a part of our subject Advanced Machine Learning, conducted by Professor Nishit Kotak. So, let us begin with the introduction of none other than artificial intelligence, or most commonly known as AI. So, what is the definition? AI refers to the simulation of human intelligence in machines programmed to think like humans and mimic their actions, just like in the GIF as you can see here. The robot is playing chess with a human. It also incorporates NLPs and in the field of robotics or even the machine learning. So, what is the significance of AI in these modern times? The AI plays a vital role in the current industry and efficiency along with the decision making in the field of healthcare, finance, and other corporates. So, what are the applications of AI? Currently, the main applications of AI booming currently is none other than the large language models such as ChatGPT, Gemini, and other such models. Along with that, there can be some autonomous vehicles in the finance sector, such as analytics for the loan procedures, and of course, this example of number plate recognition, easy for the e-challans or even detecting the vehicles. So, this was all about artificial intelligence. So, what more? Machine learning comprises of artificial intelligence, and let us begin to understand machine learning. So, what is machine learning? Machine learning refers to algorithms that allow computers to learn from and make decisions or predictions from the already provided data. The data just processes and goes through these artificial neurons, and with the help of that, the machine learns about the data and can well predict and just make decisions on their own. Isn't that surprising? So, then what is the difference between AI and machine learning? Here is the pyramid. The topmost is artificial intelligence and it comprises of machine learning, and deep down there is deep learning, obvio. While artificial intelligence encompasses a broad range of technologies designed to mimic human intelligence, machine learning is a specific approach within AI that uses data for the suitable approach for the specific things, and it uses the data for anything and everything. So, what are the types of machine learning? First is the supervised machine learning, where a labeled dataset is already available, easier for the machines to just learn and predict for the future. Another one is unsupervised machine learning. It involves training a model and data with a labeled responses. It actually aims to identify patterns or groupings in the data and is commonly used in clustering tasks like customer segmentation and market basket analysis. Now, there is the third type of machine learning, reinforcement. Reinforcement learning focuses on training models through a system of rewards and penalties, motivating agents to perform actions that yield optimum outcomes. For instance, you can just imagine a baby learning to crawl and then eventually learning to walk. This is exactly just like it. Reinforcement learning. So, this was the base part of how we can understand in the field of AI and ML. Now, let us now deep dive into Bayes' theorem. But before that, we need to understand something about probability. You must be aware about it actually. Probability theory is the mathematical framework for quantifying uncertainty. It provides tools to model random phenomena and to determine the likelihood of events occurring based on the known information. So, what is Bayes' theorem? It expresses the relationship between conditional probabilities. The formula here updates the probability of hypothesis A given the evidence B which has already been occurred. So, what are the actual applications of Bayes' theorem in real life? Bayes' theorem is widely applied in fields such as medicine for diagnosis, finance for risk assessment, and machine learning for predictive analytics. It helps refine predictions by incorporating new data based upon the experience. That was about the Bayes' theorem. What about the Bayesian machine learning? The Bayesian machine learning integrates Bayesian statistics with machine learning. It models uncertainty in data and incorporates prior knowledge, allowing algorithms to adapt as new information becomes available through the new experiences gained. So, what are the key concepts in Bayesian ML? At the core of Bayesian ML are the prior distributions, likelihoods, and posterior distributions. These components work together to form a comprehensive model that improves predictions through iterative learning. Let us compare traditional machine learning with this. Unlike traditional machine learning approaches, which often estimates parameters based upon the data which is already fixed and which is already there, this Bayesian machine learning incorporates prior knowledge and continuously updates the data as more data becomes available, enhancing robustness and adaptability. Let us conclude with an example. So I'll be taking example of a car for Bayesian analysis. Now imagine a scenario setup where you have been in a F1 pit stop and you need to predict the car performance for the further laps. So in this scenario, we aim to predict the performance of the F1 car based on various parameters such as engine size, weight, and fuel type, along with the tire wear. Collecting historical data on these features allows us to establish prior beliefs about the car performance metrics. So, actually applying Bayes' theorem to this example. Utilizing this theorem, we update our predictions as new performance data becomes available. For instance, if recent facts indicates better fuel efficiency than expected, we can just adjust our beliefs accordingly to improve our accuracy and maybe even enhance the fuel range of the car, which can allow for the more laps and for the more winning positions. Just like this example, we learn from our experiences, right? This guy here is learning from his experience about low fuel and how much more the car can run. So, what are the merits of using Bayesian machine learning for this kind of predictions? Bayesian machine learning offers flexibility in modeling uncertainties and allows incorporation of prior information, enhancing predictive performance. It also provides clear method for uncertainty quantification in car performance predictions. So, this was all about this Bayesian machine learning. I hope you understood every concept about this video since I covered from the base part. Thank you.